Welcome to lesson 1.1 for Math 1. This is going to be on number sets and sign numbers. And this is the first lesson of this course, and so I just want to go over a couple of things as we're talking about approaching lessons and if you're absent for class and how we make these lessons up. So we'll have a number of things that we'll go through on the videos, but then there'll be sections where you'll work some problems by yourself. And so when you run to those areas where you're going to do some practice problems, let's see if I can find an example here. Here's some practice problems. When you get to that point, the recommendation is to pause your video, work a problem, then unpause it, check your answer, then pause it, work the next problem. But the one thing we want to avoid is just working through or just copying down all the answers as you go. So when you get to those problem sets, I'll ask you to pause the video and start working through the problems. And your goal there is to try and recreate the classroom environment. The best education you're going to get is being there in the classroom. But when you can't be, I feel like these videos are like the next best thing. So if you use them right, take your notes, and then when you get to the practice problems, practice like you would in class. You're going to try it out, you're going to see how you do on it, and then you're going to check that answer. That's giving you feedback. So if you got it right, you can be like, okay, I know what I'm doing, this feels good, I got this. But if you're getting the problems wrong, you can use that opportunity to kind of think why, what the issue is, or if you can't figure out the why, then you know this is what you want to come ask questions about the next time you're at class. So this is really, I want to really try and recreate that learning opportunity that you would get in class. All right, so the first day we went ahead and just started this conversation. Why do we have math? And so just take a moment, think about some ideas of why we have math, like where did it come from, and just kind of jot down your ideas. So I recommend, once again, pause the video, write down kind of your ideas, unpause, and I'll kind of go over what we discussed in class. Okay, so hopefully you've written some of those ideas down. So some of the things that we talked about in class, ideas that our students brought up, it's one way that we keep track of things. So to keep track of things, things. Money was a big one, right? To keep track of money. Another suggestion was that we have math to solve problems, and not just solve math problems, but to actually figure out things using math. And then another one is we use it for measurement, and we'll talk specifically about measurement in this class. And another thing that was brought up is that we created math. Like, as humans, we came up with this stuff. And we did that for a purpose. And then this is my own little addition to this, and that we created math, or the reason we have math, is to make things more efficient. Efficient. And so that's really, I'm going to focus on the next part of the lesson, is to talk about how math does make things more efficient. So my next question is, well, what do you think the very first math humans ever did? What did that look like? And so we talked about, well, could it be addition, subtraction? Yeah, those are pretty early up there. I agree. But I think the very first thing we learned how to do is to count. Right. So counting is probably the first thing that we started doing, because you can't do any of the other math until you establish numbers and what they represent. So they had to come up with words to represent a certain amount, or they would use just like hash marks, right? So to represent certain values, but in some way we would track how many we had of something. And then from that, we come to the first operation of mathematics, which is addition. Okay. And so with addition, this is kind of how I envisioned it occurring. So let's say we had to collect firewood for the night. And so we sent people out to go search for firewood, and say, I don't know, somebody brought back like 15 pieces of firewood and somebody else brought back 12 and another person brought back 11. And so this was the firewood that was collected. And the question, okay, well, how much firewood do we have? Well, we could take all of these, put it in a pile, and then count them out one by one to find out how many there were in total. But this would take a while. It's like, well, couldn't we devise a system that's quicker, that's more efficient than just recounting all the wood that was brought in? And that's where we came up with this system of addition. Okay, so we have the 5 plus the 2, that's 7. So 5, 6, 7, 8. 8 there, then 1, 2, 3. All right, 38. So we have 38 pieces of firewood. And so addition, we came up with addition so we wouldn't have to recount. To find the total. So this is definitely more efficient. Okay, so we go through the night, we burn some firewood to stay warm, and let's say during the night we burn 14 pieces of firewood. How much firewood do we have in the morning? Well, do we need to recount all the firewood that's left, or could we come up with a system to find out how much firewood there would be? And that's where we get subtraction. So if we had 38 pieces of firewood and we burned 14, we could say, oh, we have 24 pieces left using our subtraction versus recounting these 24 pieces that were left over. So subtraction, if we remove some items, in this case pieces of firewood, we don't need to recount. And so I'm not suggesting this is exactly how it happened, but I think the principles are sound. That the idea of addition was so we wouldn't have to recount stuff. The same thing with subtraction. If we take some away, we don't have to recount. We now have a system to kind of track that. Okay, well then what operation would come next? Well, as society got bigger and more advanced and we started trading with other groups of people, we would need to track things. Let's say I got a bunch of chickens and they're laying eggs. And so I'm going to start selling eggs. And I'm going to sell eggs at $5 a dozen, right? $5 a dozen. And let's say everyone in class buys a carton of eggs. How much money did I make? Well, let's say there's 12 people in class. And so if I had 12 people in class and I sold each of them a carton of eggs for $5. So here we go. There's 5 and 5 and 5 and 5 and 5 and 5. Okay, that's 6 5s. I got to keep going. 5, 5, 5, 5, 5, 5. I better scoot that out because you can't see all of that. All right, well, I think that's 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's how much money I made. This looks like a horrible, inefficient problem, isn't it? So I do believe the answer is 60. That's how much money I would make. But this is a horrible way to set it up. What if I sold, 53? I'm going to put 53 5s. This is not efficient. So we had to come up with another way. So we came up with multiplication. So this problem here that we're seeing as an addition problem can be changed to a multiplication, because multiplication is repeated addition. So if I had 5 12 times, right, because I sold 12 cartons of eggs, that's literally 5 12 times, or 5 times 12, which is 60. So multiplication made this a lot simpler, a lot quicker. And then just to put another example there, if I had 3 plus 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 3, I do believe there's 8 of those. If I add 3 8 times, that's 24. And 3 8 times is 24. I'm going to skip ahead. Division is going to be over here, but I don't want to do division yet. I want to talk about one other type of operation. And I want to talk about exponents. Because exponents are related to this idea of something, a repeated process. And so as we talk about exponents, what I'm thinking about is that if we have, well, let's say you have a virus. So that little circle represents a virus. How does a virus make us sick? Well, this virus splits into 2 of them. So we had 1, now we have 2 of them. And then a little while later, these each split into 2 more. So this one becomes 2, and this one becomes 2. And now we have 4 viruses. And then all of these split 1, 2, 1, 2, 1, 2, 1, 2, and now we have 8 viruses. I don't want to draw any more circles. I hope you guys are okay if I just continue on. If they split again, you'll get 16 of them. They split again, it becomes 32. It grows pretty quick. 64. This becomes 128. So if the viruses keep splitting, they grow fast pretty quickly. And then this is how we wind up getting sick is, yeah, we may start with 1 in our body, but as they start multiplying, they multiply pretty quickly, and then suddenly you have hundreds or thousands or tens of thousands in your body. And then your body's trying to fight that infection off. So exponents, they're repeated multiplication. So how do we express this? And how do I write repeated multiplication? I can't use this, right? 3 times 8, that is multiplication. That's a repeated addition of 3. And I want to just point out there's a lot of ways you could write 3 times 8. You could do a 3.8. That means 3 times 8. You could do 3 in parentheses and an 8 in parentheses. That is also 3 times 8. And you actually don't even need both parentheses. You could do 3 with just the 8 in the parentheses, or you could do the 3 in the parentheses and the 8 afterwards. If a number is next to a parenthesis, it implies multiplication. And if 2 parentheses are next to each other, it also implies multiplication. So we have all these ways to write multiplication, so we can't use it here for exponents, right? This is repeated multiplication. This is multiplication 1 time. So we got to be real careful on how we do that. So what is this exactly doing? We are multiplying by 2 every time. So let's say I want 2 times 2 times 2 times 2 times 2. I want to know what this value is. Well, to express that in a simpler form, I could put 2, and then what they decided to do is we're going to say, well, this is being multiplied 5 times, right? It's 2 times 2 times 2 itself 5 times. We put the 5 up here. So we make it smaller and we raise it up. And that means repeated multiplication, right? This means this is multiplication, which is repeated addition. So these are absolutely different. So when you see this is not 2 times 5. If I wanted 2 times 5, I'd have to write it one of these ways. This is 2 times 2 times 2, 5 times. And this answer actually is 32. It's this one here on that list. All right, the last one I want to talk about is division. So division, this is when we have to take a value, or take a value and divide it into equal groups. So I don't like using the word divide in the definition of division. So we want to create equal sized groups. So as an example, if we went to an orchard and we picked 72 apples, and there was 8 of us, so 8 people picked these apples. How many apples should each person get if we're going to divide them up evenly? And so I don't really define division like as the opposite of multiplication, as in like repeated subtraction. You could do that, but like I don't know how much to subtract from here. So I've got to be kind of real careful, other than if I take 8 away from here, that's going to give everybody one, each of the 8 people would get 1 apple. So if I do 72 and I subtract 8 from it, that gives me a 64. That means 1 apple per person. So each person gets an apple. And if I subtract 8 again, that's going to put me at 56. And now we have 2 apples per person. I'm not going to keep writing apples per person. If I subtract 8 again from that and divvy them out, then we would have 3 apples per person. So that is going to be 48. And now we're at 3 apples per person. Subtract 8 again. We're now at 40. That's 4 apples per person. This is not a great way to do this, by the way. I'm not suggesting this is the way we should solve our problem. So now we're at 5 apples per person. Subtract another 8. We're at 24. Now we're at 6 apples. Subtract another 8. We're at 16. Now we're at 7 apples. Subtract another 8. We're at 8. That is 8 apples. And subtract another 8. And we're now at 0 apples. That means each person got 9 apples. So we could do that. We could literally get 8 apples, pass them out to each of the 8 people, and then do it again, and then do it again, and then do it again, and then until all the apples have been divvied out. Or we can come up with a system of division. So that's kind of the way I look at these operations, that we came up with these so that we could do this counting faster. So we could be more efficient with the way we tried to solve problems. And so these are just tools: multiplication, division, exponents, even addition, subtraction. These are tools we developed to make things quicker and faster. Right, this is going to be the end of part 1. What I try to do is make 1 video per page. And I know this one's long, but I covered a lot of kind of beginning stuff with it and talked about some other stuff besides the lesson. The other ones will not be this long. So I usually just go a video per page. So this lesson has 6 pages, so it'll have a total of 6 videos. So please go ahead and continue on to the next one.